This is Origin Stories, the Leakey Foundation podcast. I'm Meredith Johnson. Throughout most of human evolution, our naked, mostly hairless, sweaty skin has been our primary interface with the physical and social environment. Our skin is our largest organ. The average adult has 21 square feet of it, containing more than 11 miles of blood vessels. Our skin protects us, and through it, we experience an incredible range of sensations. It's an interactive barrier between us and the elements, and it sends signals to our fellow humans. It flushes with excitement or embarrassment, bruises when we're hurt, changes as we age. Our skin provides a canvas for us to decorate with tattoos and makeup. So it's not surprising that our skin is such an important element of our experience of being human. And one thing that everybody can see is that our skin comes in a gorgeous spectrum of colors. How and why did this variation evolve? And how did it come to pass that this natural human variation would be used to put people into harmful and false categories known as race? On today's episode of Origin Stories, Leakey Foundation grantee Dr. Nina Jablonski explains the evolution of human skin color, the history of color-based race concepts, and how these concepts have been used in the service of colonialism, oppression, and discrimination. Nina Jablonski is the Evan Pugh University Professor of Anthropology at Penn State University. She's a member of the Leakey Foundation's Scientific Executive Committee and the National Academy of Arts and Sciences, among many other honors. She's been researching the evolution of human skin and skin color for around 25 years. She's the author of several books, including Skin, A Natural History, and her recent children's book, The Skin We're In. She is actively involved in anti-racist education and new approaches to science education to help people better understand evolution and human diversity. Her Leakey Foundation lecture was recorded at the Houston Museum of Natural Science in September 2018.
What a terrific museum you have here. This is my first visit to this museum, my first visit to Houston. I'm enjoying it very much, and I'm extremely grateful for the wonderful welcome I've received so far. The artist Angelica several years ago started making photographs of people in her native country of Brazil because she was fascinated by the fact that human coloration grades, there is no discontinuity. She said, look at this wonderful chromatic spectrum that we see in human skin. There are no barriers. There is just shades of different lightnesses and darknesses. She put them next to various Pantone colors, and her work has become world famous because she has shown that, in fact, human skin color has no discrete boundaries within it. I share her fascination with skin color, but mine comes from a different origin, not so much the artistic one, but why do we have skin that comes in colors? This is a fairly unusual situation for primates, as we'll see, and I wanted to know why. Most of our relatives don't look like us. You didn't have to come to a Leakey lecture to figure that out, but we are the only one of the primates that has mostly naked skin. All of our close relatives shown here are the rest of the African apes, and the other apes and old world monkeys are all pretty hairy guys. And when we look at their skin, they have mostly lightly colored skin under their fur. So the question arises, how did we come to have mostly naked skin that comes in a range of colors? We began working on this problem close to 25 years ago. And we realized that in order for us to study the evolution of skin color, we had to first figure out what was going on in the early ancestors of modern humans. So going back into the genus Homo, and then beyond that, even deeper in time, to the genus Australopithecus and earlier hominins, to try to figure out, hey, what was going on there? What was going on with their skin? Paleontologists love fossils, okay? Beautiful, lovely. You have gorgeous halls full of them here. But rarely do we have skin preserved in the fossil record, and so we don't know what the physical interface between that wonderful individual and the outside world looked like. So we have to rise to the challenge of summoning all sorts of available evidence, paleontological, paleoecological, anatomical, physiological, now genetic and biochemical also, to try to figure out what the skin of our ancestors looked like. To make a long story short, we spent a long time working on this issue, and we realized that probably the common ancestor of humans and chimpanzees and subsequent forms like the famous Lucy fossil, Australopithecus afarensis, looked quite chimp-like in their skin. And the reason that we made that deduction was on the basis of the limb proportions and the likely activity levels of this incredible fossil form. Because we can actually see from the relatively short lower limbs and the relatively long upper limbs that Lucy and her kind, although she was an adept bipedalist, she probably wasn't a big runner. She still had abilities to climb in the trees and may have even died of a fall from a tree. And so what we reasoned was that she probably did not undertake a lot of energetic bipedal locomotion, either running or walking, and would not have had to dissipate a lot of body heat from the surface of her body through evaporative heat transfer. And so that's why we reconstructed her to look much like chimpanzees in her skin, having light hair, light skin covered by dark hair. Our ancestors, as far as we know from all of the readings of the fossil record, evolved first in Africa, and all of the major events in human evolution occurred in Africa, and most specifically under intense solar radiation close to the equator in Africa. My favorite of all graphic descriptions that I use in my lecture is what I call the hairy timeline of human evolution. And on the hairy timeline, we can go back to that estimated time of the divergence of humans and chimpanzees, our closest living relatives, about 7.5 million years ago. And from the principles of anatomy, physiology, and these other fields that I talked about, what we can reason is that their skin probably was lightly pigmented, covered by dark hair, and that persisted through the time of Lucy and to about 2 million years, when we begin to see a rather dramatic change, and the skin becomes more lightly haired and much darker. Let's see what's going on. Here, this beautiful specimen from the West Turkana site in Western Kenya looks very different from the Lucy fossil. Here we have an individual, a young male individual, from what we can tell, who had much longer lower limbs than upper limbs, really very modern looking in his skeleton. And when we look carefully at the configuration of the hip, knee, and ankle joints, and at the internal architecture of the bones, what we see is an individual who was doing something much different than Lucy. He probably could still climb trees, but was not an adept tree climber. Rather, he was a runner and a fast walker, and he probably did a whole lot of it. We tend to think that humans are very clever and that they always evaded predation. Most of the time, humans in our history were running away from predators. We weren't the predators ourselves. So why the excellent running abilities? Probably for chasing down some animals, but mostly for running away from predators who also were sharing our open environment in equatorial Africa. So when we reconstructed the skin of early members of the genus Homo, like the Turkana boy, we reconstructed it to look quite different from that of Australopithecus afarensis, mostly naked and capable of great sweating abilities. For reasons that I won't go into in great detail, the ability to sweat liberally was an important innovation in the genus Homo and early human evolution. Sweating made it possible for us to lose a lot of internal heat that we build up through muscular activity while we're exercising in a hot environment. So it was a real winner. Humans can't lose heat through panting and other means that other animals use. We lose heat from the surface of our skin primarily. And so having naked and sweaty skin was really important. Important also is the fact that through most of human evolution, through most of certainly the genus Homo and Homo sapiens evolution, naked, sweaty skin has been our primary interface with the physical and the social environment. It's salutary to reflect on the fact that, yes, we wear clothes today and we live in all these wonderful dwellings and work indoors and so forth. Humans did not have needles to create sewn clothing until 20,000 years ago. Mostly, we were running around with some things perhaps strewn over us or loosely tied around us, but mostly we were naked. And the skin was our primary interface with the environment. That is why we see it undergoing so many dramatic changes. That is why it is such a superb object lesson for human evolution and natural selection working in human evolution. In the work that we have done, and here I reference the we, my husband, George Chaplin, and I, who have worked together on this project for many years. George is a GIS professional, Geographic Information System professional, and he works in spatial statistics. And he was able to really undertake the extensive mapping and statistical work that forms the foundation, the empirical foundation for our studies. One of the remarkable bodies of evidence that we were able to draw upon in our research was provided by NASA. Their total ozone mapping spectrometer, which still orbits the Earth, provides wonderful, precise data on levels of ultraviolet radiation at the Earth's surface. And we, specifically George, were able to map this in lots of different ways. What I've shown here is one map that we created out of literally hundreds that shows annual average ultraviolet radiation at the Earth's surface. What you see in these hot pink and red areas near the equator are the highest areas. The cooler tones going into gray are the less intense shades. What we can see is a few things. Firstly, that near the equator, UV is very, very high. And in the drier areas near the equator, here, the Horn of Africa, here in the Atacama Desert of Peru, as well as some areas in islands Southeast Asia, the middle of the Pacific, and here in the Tibetan Plateau, where the pack of atmosphere is very thin over the very high mountains and plateau, we have extremely high levels of ultraviolet radiation. But those levels taper off quickly as we get outside of the tropics, so that by the time here we're around the Mediterranean, we have sort of moderate levels of ultraviolet radiation. And here in the far northern part of the old world, where some humans end up dispersing about 50,000 years ago, there's very little. This map is the key to understanding the evolution of human skin color. Ultraviolet radiation is not created equal. There are very high intensity rays that are mostly absorbed by the atmosphere, and then UVA and UVB that do penetrate the atmosphere to varying extents. If we look at the situation at the equator, let's say at the autumnal equinox, which we just passed, the UV is going to be falling, or the sun's rays are going to be falling directly on the equator. Most of the UVC will be absorbed by the atmosphere, but some of the UVB is going to pass through the atmosphere to the surface of the Earth, as is all the UVA along with visible light. So at the equator, we get this terrifically high load of ultraviolet radiation, which is mostly extremely harmful to life on Earth. But ultraviolet radiation, although we talk about it in mostly negative terms these days, was one of the most creative forces in all of biological evolution, because all organisms had to adapt to its presence. And early organisms on Earth had to adapt to extremely intense ultraviolet radiation before the atmosphere was built up. So what we have in early members of the genus Homo is naked skin, sweaty skin, able to lose a lot of body heat through evaporative cooling, and mostly dark skin, very dark skin, imbued with natural sunscreen, the pigment eumelanin, or more simply, melanin. Melanin is nature's sunscreen, and it's used lavishly in nature, not just by primates, but by all sorts of vertebrate creatures, including lots of birds and many invertebrates. It's one of these molecules in evolution that just gets continually repurposed because it does its job so well. It absorbs visible light. It also absorbs harmful ultraviolet radiation. And so it's recruited over and over and over again. Humans, like their non-human primate relatives, can make melanin in abundance in their skin under particular conditions. And under particular genetic conditions, and under conditions of high UV, our ancestors made lots of protective eumelanin in their skin. Eumelanin is a complex polymer, and it's incredible. It actually doesn't really have an end. It's sort of like a big long piece of rope, and you basically just have to sort of chop it in order to make a piece of eumelanin. And it's just fantastic because it not only absorbs ultraviolet radiation and visible light, it can also chemically neutralize reactive oxygen species that are formed by solar radiation. So it does many kinds of beneficial jobs as a sunscreen in the skin. Now, when the ultraviolet radiation is impinging on the skin, this is a diagram that I made with, this is the atmosphere here, oxygen and ozone. Here's the epidermis of your skin. This is darkly pigmented skin where the UVB is actually being attenuated, slowed down. There is still some passing through, but much less. UVA is still passing through and is causing quite a bit of damage. But what we see here is that the UVB will be slowed down a lot, greatly attenuated by the dark pigmentation, thus sparing the underlying tissues. In the course of our work, we collected huge amounts of data on skin color amongst all the world's indigenous peoples. We found comparable bodies of data, and we did lots of statistics. And what we were able to show is basically there is an extremely high correlation between skin color of indigenous peoples and ultraviolet radiation, to the extent that 86% of the total amount of variation in skin color in humans can be accounted for by variations in ultraviolet radiation intensity. For those of you who are biologists or statisticians, you know this is pretty good. You know, we don't get this kind of statistic very often, and it indicates very strongly a cause and effect relationship between intensity of ultraviolet radiation and darkness or lightness of pigmentation. Now, when people first started thinking about reasons for the evolution of skin color, they said, oh, listen, it's got to be down to DNA damage caused by ultraviolet radiation that leads to skin cancer. That's got to be it. And in the 1940s and 50s and early 60s, this was the prevalent explanation when any explanations were put forth. Even before DNA structure was known, it was thought, okay, the dark pigmentation in human skin protects against skin cancer. And then a very clever biologist, Harold Bloom, in 1964, wrote a sort of an inconvenient paper because he pointed out, listen, people get skin cancer when they're past reproductive age. How can this be an evolutionary explanation? Malignant melanoma, the most serious of the skin cancers, is extremely rare. How can this have a statistical effect? And so from the mid-60s onward, the explanatory framework for the evolution of skin color more or less unraveled. Some people ventured parts of hypotheses, but a lot remained unexplained. And so when I picked up on this years ago, I couldn't believe how little was known. And I was actually disconcerted by this when I was trying to teach a class about the evolution of skin and skin color. I thought, how can something that is so important to our lives as physical and social beings not be well known? And it's this, at this time, when I began to realize, as a result of reading and some wonderful serendipitous events, including listening to a seminar given by a very bright colleague, when I realized that the key might be in a place where we never expected, that ultraviolet radiation may have an effect on an important vitamin that in turn affects reproductive success. What we recognized was that ultraviolet radiation can actually break down various forms of folate, the B vitamin that is necessary for DNA production and cell division. And the important lecture that I went to that keyed me into this was one on the relationship between folate deficiency and birth defects called neural tube defects. And I realized, oh my goodness, if we have a molecule that is necessary for life, for DNA production, that's necessary for normal development, and it is degraded, at least in part, by ultraviolet radiation, this could be a mechanism. Folate is an amazing, important vitamin. Since the 1980s, there's been a lot of fortification of foods, especially foods that are going to be eaten by young women and men of reproductive age, because it's recognized that folate is incredibly important. We get it from whole grains and green leafy vegetables and citrus fruits, as well as from fortification. And it's required for all of these important processes, for actually making DNA, for repairing it, and for regulating it through the process of methylation. Now, this is you, right? Now, you didn't think you looked like this when you were 23 or 26 days old as an embryo, but this is what you looked like. And that precise cell division and choreography of cell movement in the early mammalian, including early human embryo, is thanks to plentiful cell division fueled by ample amounts of folate being provided from the mother's circulation. If folate stores are inadequate, or if folate supplies are inadequate, this important neural tube, which is the primordium of the nervous system, the brain and the spinal cord, doesn't fuse properly. And so any number of different kinds of birth defects called neural tube defects can be formed, the most common of which being spina bifida, now almost unheard of, but 20, 50 years ago especially, still very, very common. Almost 70% of neural tube defects in humans can be traceable to folate deficiency. So we felt that we had the beginnings of an understanding of why skin had evolved a permanent natural sunscreen, because it helped to protect folate metabolism. And as we have now worked on in recent work with my colleagues at Penn State, we're working on the effects of folate as it determines the vasodilation of arteries in the skin. In other words, how folate protects us against overheating as well. So the main selective force, because evolutionary biologists want to know, why did something evolve? What did it do for an individual so that that individual could have more healthy offspring? The primary selective force is to provide protection against UV-induced changes in folate availability. And when geneticists started working on this problem a little bit after we started, what they recognized was that there were several, in fact, now many genes that contribute to human skin pigmentation. They started working on one particular genetic locus, the melanocortin-1 receptor locus, which has often been called the key pigmentation gene, but it's one of many. And what they found was that this particular locus was probably very important in the formulation, in the development of permanent dark pigmentation in our ancestors, and that loss of any variation in this particular gene was actually key to creating dark skin pigmentation. The melanocortin-1 receptor locus determines the configuration of this particular protein on the surface of melanin-producing cells and is responsible for making this marvelous eumelanin molecule. Pheomelanin, the yellow-red form of melanin, is also beautiful and interesting, but doesn't have nearly the protective properties. And in fact, when it's subjected to ultraviolet radiation, it actually gives off reactive oxygen species, which can lead to the precursors or damage leading to the precursor of skin cancer. So eumelanin is really the hero of the piece here. And so in early Homo evolution, we have the fixation of the melanocortin-1 receptor locus in early members of the genus Homo right here, and all of subsequent early Homo and early Homo sapiens evolution in Africa glides onward, and people become increasingly dark in parts of Africa that have very, very high concentrations of ultraviolet radiation. Remember, Homo sapiens, we now know, evolved first in Africa about 300,000 years ago, and all of the salient aspects of our evolutionary history occurred there. The development of art, symbolic language, multiple tool types, it all happened there when we were undergoing this incredibly dramatic movement around Africa, adaptation, and increasing dark pigmentation in most of the sunniest latitudes. So this is how the hairy timeline ends for modern African people, and this is where a few populations begin who subsequently leave Africa. Because we know that within Africa, there are many darkly pigmented as well as moderately and lightly pigmented people. And outside of Africa, there are lots of people who are lightly pigmented, or what I would say is the more accurate term, depigmented. They have lost most of their protective sunscreen. UV is mostly harmful. Your doctors are telling you this all the time: slap on the sunscreen, wear a hat, all this stuff. It is mostly harmful, but it does one important positive thing, which is to begin the process of catalyzing vitamin D formation in the skin. Specific UVB wavelengths begin the process of converting a cholesterol-like precursor in your dermis into pre-vitamin D3 and then onto vitamin D3 itself. This is all happening very, very easily and quickly when your skin is exposed to sun that has UVB in it. Now, we were talking about this geography. Let's look back, okay, and let's look at some human dispersals here. So humans are doing all this great stuff for a very, very long time, for 230,000 years of evolution in Africa. And then we have the beginnings of some dispersal outside of Africa by a few small populations. It's really important to remember when we talk about human evolution and Homo sapiens evolution that we're not talking about marauding, thousands of people going, over land bridges. We're probably talking about dozens or hundreds who were dispersing as they pursued animals that they were hunting. What happens when you have a small group of people is that you have a great loss of genetic variability. So at all of these major sort of continent hopping events or continent bridging events, we have small numbers of people. We have founder effect, genetic drift happening. Gene pools are greatly lessened in variation. So here, humans crossing through the Afro-Arabian Peninsula, some populations going into Southeast Asia 50 to 60,000 years ago, some going into Northwestern Europe 40 to 50,000 years ago, into Northeastern Europe 30 to 40,000 years ago. Clearly, these populations here going into areas of moderate or very low UV, and particularly low UVB. You can see where we're going here, right? And where we're going is into the northern hemisphere in winter. We're heading in that direction right now. Now, me, living in State College, I have it much worse than you guys in Houston, but still, in the middle of the winter, UVC completely absorbed just like it was earlier. UVB also completely absorbed at the winter solstice in the northern hemisphere, although UVA still passes down to the Earth's surface with visible light. If there's no UVB in the atmosphere, during much of the year, there's a problem. And that problem has to be solved or else humans can't live there, because the UVB is essential for making vitamin D in the skin. Vitamin D production in the skin by UVB is by far the most successful way for us to make vitamin D quickly in our bodies and to make large amounts of it. Vitamin D is essential to human life. It's actually a hormone, not a vitamin in the strict sense. It is a hormone that has activities on virtually every organ in your body. Probably some of you have gone to your doctor in the last 5 years or so, and the doctor said to you, "You're vitamin D deficient. You've got to do something about it. Here, take some supplements, have some very cautious sun exposure." But vitamin D deficiency and sufficiency are great effectors of health. So when we have very little UVB coming down here, we have very little vitamin D formed, and this is a bleak situation. These two guys out in the same level of sunshine, the man on the left is going to, on a sunny day in the middle of summer, be able to make vitamin D in his skin at a rate 5 to 6 times faster than the guy on the right. By the end of the day, they'll both make enough vitamin D in their skin to satisfy their physiological needs, but it will happen much faster in the man with slightly depigmented skin. And it's important to remember that humans, during most of prehistory, didn't travel during their lifetimes. Think about it. Once they dispersed into a particular area, they didn't go on vacation, right? I mean, vacations are cultural productions of the last century for the most part. Humans stayed put, or they would migrate with herds of animals over hundreds or tens of kilometers, not like the travel that we engage in today. And most time was spent out of doors. Yes, there were caves and later very simple dwellings, but most of the time we spent outdoors. Again, referencing my early comments about skin being the primary interface with the environment, without sewn clothing, without a roof over our heads. And we withstood changes in UV intensity from one season to another because we were outside, and in the summer it was sunnier and our skin got darker, and in the winter it was less sunny and our skin got lighter, and this is regardless of your baseline skin pigmentation. So what's going on at high latitudes? Why is vitamin D important? Vitamin D has multi functions. The classic function is that it makes it possible for you to absorb calcium and phosphorus from your diet, something that's absolutely essential in the maintenance or the production of your skeleton and your teeth in the first place, and the maintenance of your skeleton and teeth and your musculoskeletal system in good shape throughout your life. In the absence of adequate vitamin D, what we see is now the infamous disease called Nutritional Rickets, which pictured here in some late 19th century kids became common in many cities during the Industrial Revolution, but occurs occasionally, actually quite commonly today, in populations in Africa, the Middle East, and still in some parts of the United States, when kids don't get enough vitamin D in their diet, or they're not exposed to enough sun to make vitamin D in their skin. And if they have the misfortune to be chronically vitamin D deficient when they're growing up and they're female, their pelvis can become deformed in such a way that it precludes normal childbirth. That is natural selection in action. When something occurs that curtails or eliminates reproductive success, this is a disaster. This leads to extinction unless a change is made. We also know that apart from the classical functions of vitamin D, that there's much more known about the effects of vitamin D on the regulation of the immune system. Many people are starting to come down with autumnal sniffles as a result, in part, of lowered vitamin D concentrations in our circulation. And vitamin D is really important for controlling cellular overgrowth and preventing many kinds of cancers. So here we are, back in our beautiful map. So here, look at all these areas in the northern hemisphere, and these early or sort of mid-road Homo sapiens. Some of them are headed up here, headed over there. How is this going to work? It's not going to work at all with darkly pigmented skin. because darkly pigmented skin in the absence of dietary vitamin D is going to mean very, very poor bones, very poor health outcomes, and probably extirpation or extinction of a population within a few generations. So what we see in humans that are dispersing into these high latitudes are a combination of biological and cultural adaptations. This is the quintessential human evolution story. Biology and culture working together over the course of hundreds of thousands of years to create us today. So these biological and cultural adaptations are now becoming much clearer as the result of exquisite genetic and genomic work, as well as the work done by anatomists and physiologists like myself. And what we have described is something that we call the vitamin D compromise that includes skin depigmentation in the populations that led to Northwestern Europeans and East Asians. And what's really cool about this, if you're an evolutionary biologist, when something like this happens, you get very excited, but you get even more excited when you realize that different groups of genes that affect skin pigmentation underwent mutations in order to produce the depigmentation effect. In other words, the natural selection was so strong that whatever variation in whatever pigmentation genes that could produce depigmentation were recruited. That is really cool. You can see, I get very excited about this. And we also know, that to the best of our knowledge, similar changes occurred in the ancestors of some Neanderthals. Independently, again, an example of parallel evolution of depigmentation in hominins living under reduced UV conditions to be more conducive to vitamin D production in the skin. So here we have just the opposite of our story of photoprotection under high UV. We have many genetic loci associated with depigmentation under strong positive selection to make vitamin D in the skin. So here we are in promoting vitamin D production under low or highly seasonal UV conditions. Where do we see some of the most extreme examples of this vitamin D compromise? You can't get a more, or almost any more low light and cloudy and low UV an environment than Scotland. And here in Scotland, we see individuals with some of the most highly depigmented skin, and that wasn't enough to keep them healthy. In order to live under such low UV conditions, even in the summer, they had to supplement their diets with vitamin D-rich foods. And not just supplement the vitamin D-rich foods like codfish and cod liver had to form the core, the staple foods of the diet. What we see throughout the northern part of the northern hemisphere is a dependence of people on vitamin D-rich foods, requiring the technology, of course, to harvest them in the first place. So depigmented skin plus harvesting vitamin D-rich foods, a biocultural compromise to allow people to live at extremely high latitudes. The vitamin D compromise also involved genes that affect vitamin D metabolism and its production in the skin, which is really interesting. Vitamin D-rich diet. And so when we look at skin pigmentation, we know that it's strongly related to ultraviolet radiation intensity, but it really is a compromise between the two conflicting evolutionary forces of photoprotection, protection against intense UV near the equator, and photosynthesis of vitamin D closer to the poles. These two clines meeting together in the mid-latitudes. What people do we find here in the mid-latitudes, in the circum-Mediterranean, and in the far tip of South Africa, and in much of the neotropics? We find people who have moderately pigmented and highly tannable skin. People who can gain a lot of pigmentation and lose a lot of pigmentation according to the intensity of UV in the sunlight. And the genetics of skin pigmentation continue to unfold and amaze. Tanning, as an ability, has evolved from multiple genetic substrates multiple times. Similar skin colors, both depigmented, darkly pigmented, and highly tannable skin colors, have evolved multiple times independently under the same UV conditions. Very, very, very beautiful evolutionary biology. And importantly is that we see similar skin tones evolving independently of other traits. So when we think about, oh yeah, well, how is that skin tone related to hair color and hair texture and eye color? Well, basically, from a genetic perspective, almost completely unrelated. So we have skin pigmentation genes evolving entirely or mostly entirely independently of genes that determine other aspects of our physical appearance. So think about this in terms of the classic definition of races. This is something I work on all the time. How do people think about race? They think about these discrete packages of biological and even behavioral traits. These packages don't exist in life. These packages, these discrete boundaried packages of genes don't exist. And I'm happy to say that our work on the evolution of skin pigmentation has helped to push this whole area of inquiry about the origins of human diversity and how we talk about it forward. This is a discussion that we all have to have. How we got to look how we are is a fantastically interesting story. And humans now look at in beautiful plenitude in every shade of the sepia rainbow all over the world as they've dispersed, undergone depigmentation, repigmentation, tanning, untanning, just an amazing array. You have skin. You can teach human evolution and natural selection using your skin. When teachers talk to me about, how can I teach evolution in my classroom? I say, listen, one of the best ways available now is using the story of your own body, your own skin color. This is the teaching tool that you carry with you. Cheap, available, perfect. Use it. It's an excellent example of natural selection acting on the human body. We are mammals, primates, just like the rest of them, subjected to the forces of evolution and conspiring with culture during much of our evolution, our recent evolution, to come up with all of these wild and wacky compromises that allow us to live in the extremities of the environment on the Earth's surface. Skin color has tremendous numbers of implications, tremendous for our health and social well-being. We pay attention to color. Color is important for us. We can't help but see color. That's one of the beauties of being an old world higher primate, is that we have trichromatic color vision. But the fact that we see it doesn't mean that we judge it. The bald assessment of color is completely neutral and free of any judgment. We only affix a value to color through behavior, through acculturation, through exposure to people who have views about color. I like, and this is one of the illustrations from my kids' book, I like to talk about the conditions that existed for much of the time in ancient Egypt as people lived along the extent of the Nile from areas right on the Mediterranean here with moderate levels of UV to areas here in the tip of the Red Sea, close to the tip of the Red Sea in northern Sudan, with very, very high levels of ultraviolet radiation. So along the upper and the lower Nile, we see this tremendous gradient of UV radiation and this tremendous gradient of skin color among the various peoples and pharaohs of dynastic and pre-dynastic Egypt. People living along the Nile traded with one another regularly. They saw the difference in skin color. They depicted it in art, in sarcophaguses and in other murals along the Nile. But color did not distinguish one group from another in terms of anything but the bare color. There was no value associated with color. For us living in the United States right now, it's almost unfathomable to think that there was a time in human history, and in fact, most of human history, when we affixed no value to skin color. There were no connotations of skin color. But in fact, that is the case. Humans are very, very good at discriminating according to language and dress and, perceived barbarity. But for most of human history, those boundaries were not drawn on the basis of skin color. So here I like to quote, to look at the Persian Empire and all of these different empires here that were described at 540 BC. Really, really interesting time in human history when humans lived in cities, when they were extremely sophisticated, literate, well-read, and people were of all different colors, language groups, and backgrounds. They distinguished one from another, but not on the basis of skin color. So that you would have people with very dark or very light skin that were equally considered barbarians, for instance, by the Greeks. This is, I think, a fascinating and, again, very beneficial thing to reflect on, that we're very good at making groups out of humans, us and them groups, but the kinds of groups that we created in the mid-1700s, the so-called races of humans, were created by a few guys on the basis of their own opinions. They were not created on the basis of ancient patterns of color-based discrimination. Carol Linnaeus, the founder of modern systematics, first described humans in 4 different varieties that he didn't call races, he called them varieties, and he didn't rank them. But he said, basically, you've got white Europeans, you have red Americans, you have brown Asians, and black Africans. So 1748, very, very simple. That's how he describes them. And he's got humans and lots of other primates and lots of plants and other mammals. And it's he's doing a lot of basic systematics. 10 years later, after he reads a lot more travelers' accounts of human variation, including variation in behavior brought back by explorers, we have Linnaeus talking about people who have different color. Okay, so here Americans red, but they have a choleric disposition. Europeans, white, sanguine. Asians, brown, melancholy. Blacks, Africans, black and phlegmatic. Where did he get this? This is stuff that he is taking from the old climatic theories of ancient Greek times, and unusual for him, making a scientific explanation of diversity that includes pejorative terms, pejorative references of behavior. Over time, things just get a bit more exaggerated. Immanuel Kant, one of the foremost philosophers of Western civilization, was fascinated with problems of human diversity. And in 1775, began a series of essays on the different human races. And he continued this through the early part of his career because he was trying to understand how the physical appearance of humans was associated with their potential for moral behavior and the development of civilization. And he was convinced that color was the key to understanding this. It's beneficial to reflect on the fact that Kant hardly ever left his sitting room. A very, very erudite man, brilliant, absolutely superb philosopher in many of his writings, but when it came to understanding human diversity, he only heard secondhand, third-hand, and hearsay reports, and he had very strong opinions about who was better than whom. He created, and Kant was the first one to create 4 distinct races that he referred to as races that had no mixing in between them, no sort of gray zone, as it were, between these races, that they were completely separate entities, unmixable, and that they had different capacities for civilization. And of course, his race was on top. Kant and his Scottish counterpart, David Hume, had very similar thoughts, and they had very similar data to go on. They received information from travelers' tales, explorers, that was very poor quality compared to the information we have today on human diversity. And they made very clear judgments about people who were not Europeans. David Hume said there was never a civilized nation of any complexion other than white. These two were the Hume-Kant view was tremendously influential. They both held that races were physically and culturally distinct from one another, and that the white race was supreme. Now, this paradigm, as we could say, had tremendous effects. Remember, where are we in history? We're in the middle of the 1700s. What else is going on here? Unfortunately, a lot. Both of these guys were very highly regarded. Their books were widely distributed. There were printing presses. Books were precious, but they were widely distributed. They were widely distributed throughout Europe and into the American colonies. Their writings were favored by scholars and statesmen, including the so-called founding fathers of the United States. And all of this happened at a time when the transatlantic slave trade was going great guns and was under fire. In England, the abolitionist movement was beginning to grow, and there were calls for the abolition of the slave trade, which had already been going on for 250 years. But if you have what I would now call pseudoscientific accounts of races and racial hierarchies, such as those propounded by Kant and Hume, what is this going to do to the transatlantic slave trade? It's going to support it. How convenient. Have pseudoscience supporting a completely bankrupt and inhumane trade in human lives. And we have the same kind of pseudoscience that bolsters some pseudo-religious accounts, the biblical defense of slavery, among many others, written in the early and mid-1800s, that takes these so-called races of humans that have been described, puts them in a clear hierarchy, and indicates that some humans, especially Africans, are destined, following the curse of Ham, to serve other humans. Very convenient if you want to promote the slave trade and maintain slavery after the slave trade is officially abolished in England. The slave trade was a pernicious trade in human beings that resulted in 14 million mostly West Coastal Africans moving to Europe, the New World, in large numbers to South America and the Caribbean, much smaller numbers to North America. But this was an absolutely horrible trade that was created on the back of racial hierarchies and maintained. So we have race definitions that begin to be formulated by men with incomplete data but lots of attitude in the mid-1700s, leading to quickly the formation of racial stereotypes in this country and elsewhere, and the formation of what I call color memes, that we associate particular skin colors with particular patterns of behavior, creating the psychosocial template for racism. We can see this in our history. We can see this in world history. We can see it just as clear as we can see the evolutionary biology. Now, what can we do about it? What we can do is we can work to teach kids about these different facts of evolutionary biology and the origin of human diversity in skin color, and the origin of the fallacy of physical races. I don't want to be so bold as to say we can tell kids that race doesn't exist. Race is a social construct. A 9-year-old doesn't know what a social construct is. But what we can tell them is that the idea of race was created by some guys who had very, very inadequate data and lots of attitude and lots of bigotry, old-fashioned bigotry. And should we listen to them now? Should our modern history be forged by the fallacies perpetuated 250 years ago? No. When we teach this book to kids, and in our summer camps, what we have are kids who learn about the evolution of skin color and the history of racial types created on skin color, and they say, what's the fuss about? This is a product of evolution, and these guys were wrong. Why are we here? That's my question for you. Why can't we get this information in our schools? And this is what I spend my days doing now. And in our summer camps, we have kids who work on their own genes, who look at their own skin and try to figure out what's going on. This Finding Your Roots curriculum, I've been working on it for nearly 10 years now with Henry Louis Gates Jr. from Harvard and many other wonderful collaborators. Geneticists, sociologists, historians, bioethicists, evolutionary biologists. It's a great group. Now over 40 strong have contributed to this marvelous curriculum. We've had grant support from the Rockefeller and Robert Wood Johnson Foundations, and we've had an excellent run of summer camps during which kids study their own DNA, their own pigmentation genes, their own relatedness. They explore their own genealogy. They look at their deep history. They look at life under the microscope in various ways. They learn about their own physiology. It's absolutely fantastic. If you go to this website, www.fyrfindingyourrootsclassroom.org, you can watch a series of 8, soon to be 9 videos that show our kids in action. You can do this in your home and in your classroom. You can do this in your after-school program or your summer camp. We have the curriculum ready for you to download free. Everything's there for you to do this anywhere you want. Skin color is a beautiful evolutionary adaptation and needs to be celebrated by all humans as just that. It doesn't divide us, it unites us. It is the most beautiful and effective product of natural selection on the human body, a wonderful teaching tool, something to be absolutely celebrated. I want all of you to do it. I want all of you to go out, tell your families and friends about this, and just spread the word, because the world will be a little bit better place with this knowledge about our evolution and our history. Thank you very much.
Origin Stories is a project of the Leakey Foundation, a nonprofit organization dedicated to funding human origins research and sharing discoveries. You can support this show and the science we talk about by making a donation to the Leakey Foundation. All donations will be matched, so your impact will be doubled. Visit leakeyfoundation.org/donate. That's LEAKEY foundation.org/donate. You can check out the video of this lecture on our YouTube channel. The link is in your show notes, along with links to Dr. Jablonski's books and her curriculum, filled with lots of information and activities you can do with your kids at home or in class if you're a teacher. You should also check out our new web series, Lunch Break Science. It's a fun show where you can meet Leakey Foundation grantees and learn about their work. It streams live on the first and third Thursdays of every month. The next episode is this week on November 5th at 11 a.m. Pacific on YouTube, Facebook, and leakeyfoundation.org/live. We also have an exciting event coming up on November 19th. The Leakey Foundation's Young Professionals Group is hosting an event on the evolution of human hair. It's going to be a lot of fun. I'll be there, and I would love to see you. Visit leakeyfoundation.org/YPG to sign up, and you'll receive an invitation to the event. If you like our show, please rate and review it. It helps others find us, and we really appreciate it. As always, thanks for listening.